So this is an example of the YouTube video that you should make for explaining your project. So first I would like for you to go through all the slides of your project just to show the route that you created. Okay. And then I would like for you to go into two different intersections and explain how you modeled the curve. And when you do this, I would like for you to select two different types of intersections. One should be a reciprocal function like this one. Another one should be a standard hyperbola function like this one. When you choose the two, if you have two different types, then I would like for you to choose two different types to explain. And if you have three of the same type, then choose two different of the same ones to explain. Okay? And in your project, you'll only have three intersections, although this project here has four. Okay? So here I'll show you how to explain a modeling intersection. So here is a 90-degree intersection, which I've tried to model using a hyperbola. And as you can see, the approximate asymptotes here should be kind of like right here. So this would be the asymptote about y equals 7 or 8, right? And then the vertical asymptote here would probably be about like x equals 6 or 7, right? So let's verify in the equation that, yeah, look at that. There's the horizontal asymptote, 7, and here is the value of the vertical asymptote, 6, right? So this is the reciprocal function transformed form, and so we have the vertical asymptote here, and we have the horizontal asymptote value here, okay? And then we have the m value in the numerator of this part. We have the value 8. And what 8 corresponds to is, since it's a positive number, we can see that that means that you're going to have two sides of the function, one in the upper right quadrant and the other one in the lower left quadrant. That's what it looks like when it's positive, okay? And then if you wanted to see what the 8 means, what the 8 means is that if I multiply, for example, the parent function x value of the point and the y value of the point, I should get 8, okay? So that means like on the parent function, some of the points that you might see would be 8, 1 and 1, 8. And so 8 is 8 kind of distances the curve from the asymptote. So instead of being like very close to the asymptote, a value of 8 might separate it away from the asymptote. Okay? And so since I wanted to go from here to here, you can see that it would be the lower left quadrant that I would use, so that's why I use the positive value there. Okay? And let's see, I'm going to choose this standard hyperbola function to explain. And a standard hyperbola function takes this form where you have the x squared divided by an a squared value minus the y squared divided by the b squared value. And in this case, it's equal to -1. And if the right side is -1, what that means is that you're going to have a top part and a bottom part to your hyperbola instead of a left and right side. Okay? And so that's why we have a -1 on the right side, because we want a top section and a bottom section. You can see why we want a bottom section, because the bottom section, what it does is it will curve from this bottom left side and then turn and go to the bottom right side, and that's what we want in this case, right? So let's look at where the center of this hyperbola is. You can kind of see that the center is about maybe like there, okay? So that looks like it's about 1.5 comma 1.2, something like that. So if you look at the h and the k values here, x minus h, y minus k, you can see that the x value is 1.6. So yeah, 1.6 is about here, right? And then the k value is 1.1. So yeah, the k value is like, so there's the center of the, or here's the center of the hyperbola. Okay, so that's where the h and the k values come from. And then you look at the a and the b values. A is 2.4, b is 1.1. If you drew a rectangle in between the top green part and the bottom green part, you could see that the height of the rectangle would be about 2. So half of the height of the rectangle would be about 1, maybe a little bit more than 1. So that's where the b comes from. 1.1 is like half of the height of the rectangle. The width of the rectangle looks pretty wide. You can see how the slope of this asymptote is probably about, I don't know, 2 divided by 3 or something. So the a value, which is the run of the slope, is going to be quite a bit more than the a value. So, or I'm sorry, this is the b value and this is the a value, right? So the a value, which is 2.4, is going to be quite a bit longer than the b value, right? Because 2.4 is a little bit longer than the 1.1, so that explains why the slope of the asymptote has a longer run than a rise. Okay? So that explains the a and the b value. So that with this particular a and b combination, it's kind of stretched out to the sides. Okay? So, and then we've explained each part of this, and so that's basically how we have modeled this function here.